Okay. So this should be background knowledge because we just spent a couple of days doing it. If I gave you an equation like that, how would you graph it? So we have to get it into its factors, right? So what Elisa's talking about is you've got to play the game, right? So you need to know the difference between these two words. If I say factor, you have to know that means play the game. Otherwise, I can't use it anymore. Now, what does it mean to play the game? What do I do? You need to find two numbers that multiply to 15 and add to -8. Raise your hand when you know which two numbers will fit those criteria. Multiply to 15, add to -8. Jason, what are they? Okay, so the very first thing to graphing this, right, is you would take that -3, -5, you would rewrite the equation, right? And then what would you do? This 3, this 5, what do those mean? What did X say at the end of it? Yeah, these are the points where X crosses the axis. They're called the x-intercepts. So if I were to graph this, if we were to graph this, it would look something like this, right? This is a review. Then we would find the axis of symmetry. We go through the middle. The axis of symmetry is x equals 4. And then what would I do with that 4? In order to find the vertex, what do we do? We need to find the y value, right? So if I plug it in, 4 minus 3 is 1. Nope, that's okay, we just plug it in. 4 minus 4 is a -1. Isn't that -1? What does that mean? That means the vertex is right here, and the graph looks something right here, right? Are you okay with that? Okay, so we plugged in x equals 4 into the equation to know where the vertex is. Okay?
Because you're finding the location of y. X is, yeah, the line of symmetry, yeah.
All right, now this was just a review. I wanted to point out a couple things. This right here, what are those called? Okay, they actually have a lot of names that can be used interchangeably. X-intercept is one that we've used. What else have we called them?
Susanna, you gotta put it away. What else have we called them?
Zeros.
Confirm, have we used the word zeros for those lines before? Yes.
Another word that we haven't used before is solutions. If I took this exact same equation right here, and instead of saying y equals, if I said 0 equals x squared minus 8x plus 15, the 0 line is this line right here, right? So this is saying, when does my graph cross 0? Well, it crosses 0 when x equals what? From here, 3. From here, what? 5. These would be the solutions of my equation. So where the graph crosses the axis, that is the solution to the equation. Our goal for today is to get a bunch of equations and solve them. Okay? So in order to solve them, we'll have to find the x-intercept. Well, we switched that -3 to a +3. I just didn't write it, I just put it straight down. Well, you don't switch it when you plug this back in. So do y'all have that? Or as much of it as you feel like you need? Yes.
So like, you keep it how it is, so like when you something else, so you could like how I don't know, it was yesterday, 8 and 16. You keep it as the negative,
So you plug these into your fraction form, yes?
and then when you get rid of it, you get the 4, and you plug it back into that one, to equate to 0.
Yes, sort of. Hey, let me tell you the difference. So on this board right now, we have 2 different days of learning. Let's do it in purple. This day of learning, this is 5.2. We are not doing that today. Okay? I just wanted to show you how what we did previously fits with what we're doing today. This is what we are doing today, 5.4. So let's keep going. So example 1. Number 1. All I want you to do is solve the equation. So if I gave you 0 equals x squared minus 4x plus 3, how do you solve that equation? Well, how do I solve that equation is the same way as finding the x-intercept. So how would you find the x-intercept if I gave you that? You have to do what? Factor. So you need to find 2 numbers, which is why we spent so much time on factoring, right? It's why I told you you have to be able to do this. Because factoring is so key. We need to find 2 numbers that multiply to what? 3 and add to -4. What happens if you switch those 2? Then you made an oops, right? It's wrong. You can't switch those 2. Now, what 2 numbers multiply to 3? 3 and 1, right? In order to get the -4, they both have to be what? Negative. Now let me back up just a little bit.
You guys all watching?
If I wanted to find my x-intercept, I would take the opposite of the -1 and the opposite of the -3, right? Let me show you another way to look at it. Is it true that if I have some number A and some number B and I want to multiply them and get 0, if A equals 0, okay, it would work.
Is that true? 0 times something would be 0. Yeah?
If B equals 0, it would also work.
Is that okay?
Now we are just going to call these numbers, this is my A, this is my B. And I'm going to write it out kind of the long way so that when we get into harder problems, it makes a little bit more sense. So if I want this entire thing to be 0, either this has to be 0, or that has to be 0. Is that okay? So if I want this entire function to be 0, either the first factor would have to be 0, because 0 times something would be 0, right? Or if the second factor was 0, then something times 0 would still be my 0, right? Kind of. All right, so let's solve them independently. X minus 1 is 0, which means x has to be what? 1. X minus 3 is 0, which means x would have to be 3. And if I wanted to check it, if I plugged 3 into here, would I get 0? Yes. If I plugged 1 into here, would I get 0? Yes. These are the solutions to my quadratic equation.
Yes. Questions on that?
Yes.
Of course. I'm not going to just do one and then set you loose and have you do your own. Let's do another one.
Pretty much. It gets a little bit more complicated when this is like a soup or something. We'll do one of those in a minute. So number 2. Solve. It doesn't really matter where the 0 is. X squared minus 19x plus 90 equals 0. So if the 0 is on the front or the back, it doesn't really matter. The first step is to do what? If we were to write steps down, the first step, this helps you. Step 1 is to factor. So you have to play the game. What two numbers multiply to 90 and add to negative 19? Negative 10, negative 9. So how do you write that? X minus 10. It's kind of important that you write this step down so you don't get confused between your factors and your solutions. So these are the factors. Now if I wanted to solve those, that means either this one would be 0 or that one would be 0, right? One of the two groupings has to be 0. So you will have two solutions. From here, which means x equals, say again, 10. From here, which means 9. Now that happened a lot faster. So the first step is to factor. The second step would be to set each factor equal to 0, and then you would solve it. So 2 steps. Yes.
So it's pretty much just like the same numbers, but just factor out.
Almost. The difference between these numbers, this was negative 10, negative 9. Now that's not always true. It is when my leading term is a 1. If it was a 5, then it would be something to do. Okay, and really, what are these? Yes, they're solutions. Where are they in terms of the graph? They're the x-intercepts. Good. Number 3. Let's do another one. Try it on your own. Let's see how you do. X squared plus 2x minus 8 equals 0. And as far as you can get. You're solving the quadratic by fractions. We're looking for two numbers that multiply to what? Multiply to a negative 8, add to 2. What multiplies to a negative 8 and adds to 2? 2 and 4. Now somebody earlier in a different class had the question, how do you know which one's negative? Well, you want them to add to be positive, which means the bigger number has to be positive, so the smaller number would be negative. Step 1 factor, step 2 what? Who got this, by the way? So far so good? Now we solve. If you want to skip this step at this point, you can, and just say x equals 2. And if you want to skip this step, you can, and just say x equals negative 4. But I do not want you skipping this step. Okay? You have to write this step down and then your answers, but if you skip the middle one, you fail. Who got this? Okay, let's try another one. Number 3. Or number 4. Now, what I want you to do on the top of your paper, I want you to write a 1, 2, 3, 4, or 5, and I'm going to walk around. This is telling me how well you feel about it. Like, I got it. On your paper, just the top, 1, 2, 3, 4, 5. Your next one is going to be x squared plus minus 10x plus 24. So write 1, 2, 3, 4, or 5 on the top of your paper. This is how well you understand the concept. I got this, we get 5. I really don't know what you're doing would be a 1. And I'm pretty sure I got it, I just really need a lot more practice. You can put that on to you, put 1 line. are two numbers that multiply to what? Multiply to 24. Now 24 has a lot of factors. It could be 1 and 24. It could be 2 and 12. In fact, 2 and 12 looks very promising because 10 has to do with 2 and 12. Is it 2 and 12? No, because in order to get the negative 10, this would have to be negative. But does that get us a positive 24? So that's tricky. It's not 2 and 12. It's 4 and 6. And they both would have to be what? And now what do we do? From here, x equals what? I skipped a step. Are you okay with that? Yep. From here, x equals? Cool. Let me give you another one. We have Yep. So really what you're doing is you're finding the x-intercepts without actually graphing it. You're finding the solutions to the equation without even graphing it. Is that okay? What? Yeah, we're done. Number 5. We have 5 and we have 6, and then I'm giving you your homework assignment. What do you do? Sorry, let me think about this carefully. X squared plus 2x minus 5 equals a negative 6. What do you do if it's not equal to 0? Then what? You have to figure out, like, so, like, when you do, like, multiply the game, you have to figure out what with those numbers would add or subtract negative 6. Ooh, that's right. Good idea, though. Good idea. Because if I went back to my A times B idea, A times B equals 6. Are there certain numbers? Can I guarantee what A has to be in order for this to be 6? There's a lot of different things that A could be. It could be 1, it could be 2, it could be 3, it could be 6, it could be negative 6. There's a lot of different things. So I can't do it this way. I have to have this equal to 0. Well, could you do something to make that equal to 0? Could we add 6 on both sides so that there is now a 0 over here? Yes. If you are given a problem, and on your homework you will have 2, where it does not equal 0, you have to force it to be 0 by adding the 1 over. So x squared plus 2x plus 1 equals 0. Now you play the game. Yeah. From this constant number at the end, because this is a constant, yes. Okay, so faster, find your numbers. So this one's a little, is it harder? What multiplies to 1 and adds to 2? Nope, that doesn't multiply to 1. There you go. 1 and 1, right? 1 plus 1 would be the 2. A bit tricky. So this would be x plus 1 or minus 1. Okay? X plus 1, x plus 1. So if I were to solve them, this would mean x equals negative 1. Do you have to list it twice? Now, if it happens in the same location, thinking about the graph, what is going on here? It is the vertex, right? It just hits it and it comes back. We're going to call this has a multiplicity. What does multiplicity mean? Multiplicity 2. It has a multiplicity of 2, meaning there are 2 factors in the same spot. I bring up this word because you will see it again in 5.3. So multiplicity 2 means that it is the same factor that happens in the same spot. Anybody's brains exploded, or are we good so far? We're good? I actually really feel like, are you good? It means that there's 2 factors happening in the same spot. Because every x squared will always have 2 answers. Some of them will just be repeaters like this. And we'll talk more about it next time. Last one. You good? Number 6. here, I think this will work. What do you do? Every other time we've made the shortcut, right? We've done straight from our factors to the bottom, right? And we're done. You can't do that this time because you have a leading coefficient of 2. Can you take the shortcut? No. So I want to remind you how to do this problem without using the shortcut. We still have to factor. The first thing you'll do is look for GCF. Is there one? No, darn. Now you are looking for two numbers that multiply to what? -6. How did we get -6?
Yeah, you multiply the first term and the last term, and we get the -6. Looking for two numbers that multiply to -6 and add to 1. What two numbers multiply to a -6 and add to 1? So remember that question that you had, and can I take my factors and just switch the signs? This is the case that you cannot. I think it was Elisa. So 3 and 2. Is my 3 negative or is my 3 positive? The 3 has to be positive. The 2 is negative in order to get a positive 1. Now I can't go straight to my factors. I can't jump there, right? Who remembers what to do? I heard it. Yes. So we're going to give them both an x. We're going to split up the middle term. It does not matter the order we write these in. 2x squared plus 3x minus 2x minus 3. We'll ignore that equals 0 for now. So we rewrite it so there are 4 terms. Anytime you see 4 terms, what do? You factor by grouping. So I'm going to pause for a second so you can catch up, watch what goes on. Sometimes I just get really excited and like plow through the math. And you're like, wow, that was a hurricane. What just happened? So are we good with this step? Okay. The next step would be to group them. So we group the first 2, group the second 2. There's this little plus in between. Don't forget, you're not going to multiply now. You just group the first 2, group the second 2. Now, what? From the first group, pull out a GCF. What do they both have? They both have an x. What are we left with? Okay. Now, if you were to switch these two and they were in a different order, then this step right here looks different. Looking at the next group, what do they have in common? A -1. What are we left with? 2x plus 3. If these two numbers are not the same, what do? You did it wrong. You start over because you made a mistake, right? I think Cry's always a good answer. Now these are kind of like together. We have to separate. We have to separate them now, right? So they both have a 2x plus 3. We'll write it in front. I realize this is a long process. And now it's factored. Are we done? No. Well, we're done factoring. But now we have to solve it. Once we factor, what do we do next? So either this equals 0, and I probably wouldn't skip this step, because that's a harder equation to solve. I can't just subtract the 3 and be done, right? Or this equals 0, right? How do I solve this first equation? 2x plus 3. The first step is what? Let's go back to like 8 squared and not 4. You have to get rid of the plus 3. This is what? -3. So let's subtract 3 from both sides. And you have 2x equals a -3. And then what would you do? Divide by 2. So what does x equal? That's your first solution. And what's the other solution? X equals 1. So do we like when they factor nice and pretty and we can just play the game and be done? Yes. Now on your homework there are 10 problems, not including the 6 that you did around the room. There are 10 problems. 6 of them
nice and pretty. 2 of them, in fact, are nice and pretty, but you have to move over a constant so it's equal to 0. This is one of those, right? And 2 of them, not exactly so pretty. You have roughly 8 minutes left of class. I need you to either write this down or come take a picture, because you can do that. Not this one. Let me find it. Let me find it. If you want me to be part of the picture. I can. That's just how it happened when we were. Okay, those are your 10 questions. Notice the first 6 are nice and pretty. They're already ready. If you want to change them all to x's, you can. Notice 7 and 8, you have not equal to 0. You have to add it back over. And 9 and 10, you have a leading coefficient. Now, by taking a picture, don't forget you actually have homework, so you should start 10 problems down. Because if you're not working on them now, I figured that everybody put a 5 on your paper and you're ready to move on to day 3. I feel like to make this critical as part of our lesson. If I didn't do this, there are several problems on your test that you need to do. I don't know how to say it's not part of the actual lesson. There was a meeting, I didn't write it. They're recording. Oh, thank you. That's right, everything's on recording. I don't know why this didn't work. Stop my recording now, though. This is your homework. Take a picture. Do a screenshot. Peace out.